Hi everyone, in today's lesson we're going to talk about how to complete the square when a is equal to 1. Now completing the square is just another way to find the roots of a quadratic equation. So before I can begin the process, I need to talk to you about what a perfect square is. So just recall that a perfect square is a number or an expression that is the result of two of the same numbers or things. So we'll say two of the same things being multiplied together. Okay, so for example, 4 is a perfect square, 25 is a perfect square, 36. They're all perfect squares because they were the result of two of the same things being multiplied together. And we've also talked about perfect squares that are letters. So we could have x squared is a perfect square, x to the 10th, x to the 12th, right? X squared because why? It's the result of x times x. X to the 10th because it's x to the 5th times x to the 5th. X to the 6th times x to the 6th, right? For x to the 12th. So that's all we've learned so far about perfect squares. But we can actually have perfect square trinomials. A perfect square trinomial is a trinomial. That is the result of two of the same binomials being multiplied together. So remember, a binomial has two terms, and these two terms I am going to multiply together. So x times x times 4, another 4x, and then 16. So if I combine like terms, I'll just get x squared plus 8x plus 16. So this is my perfect square trinomial. So what would the perfect square trinomial be if these were the two binomials being multiplied together? Well, we'll double distribute again, and we'll have x times x is x squared, x times negative 3, another negative 3x, and negative 3 times negative 3 is a positive 9. Again, combining like terms, we have another perfect square trinomial. Alright, now we're going to try to make a connection about what all perfect squares have in common. All perfect square trinomials have something in common, such that it's a trinomial whose c value is half of the b value squared. So I know that sounds weird, but let's just look at these two perfect square trinomials that we just made. Remember it goes A, B, C, right? So this C value of 16 is found by taking half of the B value, so half of 8 divided by 2 squared. So 4 squared is 16. That works. Now let's look at this one. This C value is half of B, so half of negative 6 squared. So what's that? Negative 3 squared, which is 9. Perfect. So what I want you to do now is I want you to look at these three trinomials, and I want you to determine if they are perfect square trinomials based off of this new fact that we know. Is the C value half of B squared? Well, let's see. Half of B, so B is negative 2, so negative 2 divided by 2 squared. Well, negative 2 divided by 2 is negative 1. Negative 1 squared is 1. That's the C value, so yes. And let's look at the second example. Is the C value half of B? Half of 10 squared. So half of 10 is 5. 5 squared is 25. Is that the C value? Yes. Okay, last one. Let's see, is half of B, so half of negative 12 squared, negative 6 squared is 36. Is that the C? Yes. Okay, so now that we've decided that they're all perfect square trinomials, we're actually going to factor the expression some more. So remember, we could use add multiply. That's what we learned when we factor trinomials with a that's equal to 1. So what are the factors of 1 that add to negative 2? And the answer is just x minus 1 and x minus 1. And the second problem, same thing. We're going to factor it using add multiply. So what numbers multiply to 25 that add to 10? And you should be saying 5 and 5. And then the last one, again, we want to add to negative 12 and multiply to 36. So that is x minus 6 and x minus 6. Okay, so now what we're going to do is start from scratch. If I don't give you the c value, can you tell me what it would be? So I want you to half the middle term, so half of b, square it. Half of negative 4 is negative 2. Negative 2 squared is 4. And then I also want you to rewrite the trinomial as a binomial squared. So let's see if we can notice a pattern. And let's go back up here to these actually before we do that. Would you agree that I could write this as x minus 1 squared? And this as, oh, this should have been a plus, sorry, x plus 5 squared. And this one as x minus 6 squared. So say you don't want to have to go through all the motions of add, multiply, add, multiply. There's actually a pattern. And the pattern is this part. After you have it, right before you square it, so after you have it, right before you square it, that will always give you the factor. Here, and here, and here. So you actually don't have to use add multiply at all, as long as you remember that little trick that after you have it, that middle piece is 5, that's what you would square as the binomial. So if I'm looking here, after I have negative 4, I get negative 2. So my factor is just x minus 2 squared. Okay? So let's move on to the next one. Let's find c first. Half of 6 squared. So 3 squared is 9. Now, we're going to factor this. This is going to be x plus 3 squared. Because of this part right here, it's a positive 3, and that's it. All right, in the last one, we're going to take half of 10. And we're going to square it. So that is c. And again, if I want to factor it, I'll just take the part that has been halved, and that is my factor. Okay, now let's put all this information to use to actually solve some problems. All right, let's move on to the back. All right, so the first question is saying, solve each expression by completing the square and describe what kind of roots you have. So we're going to do two different examples. The first example is when a is 1, and the second example is when a is 1, but the b value is odd. So the first step in completing the square is actually to set the equation equal to 0. First equation is set equal to 0. We're good to go. Step 2, the x squared must have a coefficient of 1, which it does, so we're good. Step 3, take half of b and square it. All right, I'm going to do this work on the side. So the b is negative 8. I'll square it, have it first, and then square. So I get 16. Now the purpose of doing this is because you want to create a perfect square trinomial. Because right now, this trinomial is not a perfect square because there's a 24 here. So we're going to make it a perfect square. So we have x squared minus 8x, And what we're going to do is we're actually going to add this 16 in, then subtract it right away. Now by doing that, it's a nice little algebra trick that allows us not to change the value of this trinomial. Because if you combine like terms, these are going to cancel and it's identical to this. It's just a different form of it so that it'll help us factor. So what we're going to do now is we're going to focus our attention just on this piece. And we're going to factor it because it's a perfect square trinomial. So if we use the rule, we remember this is half. So you take that half piece and that would be your factor. Alright, now we could actually add these two. And when we add negative 16 and 24, we get 8. Alright, and now we're actually just going to solve for x. So the first step is going to be to subtract 8 on both sides. And then we're left with x minus 4 squared. And to get rid of the squared, we have to take the square root of both sides, remembering that the square and the square root cancel each other out. So we're left with x minus 4 equals plus or minus, don't forget the plus or minus. I'm going to pull the negative out and make it an I rad 8. And then solve by adding 4. So we get x equals, always, always, always write this number first, the smaller one, 4 plus or minus I rad 8. And I believe rad 8 can be broken up more into 4 and 2. So x is equal to 4 plus or minus 2i radical 2. Now, how I got that 2i was because I knew the square root of 4 was 2, and I multiplied that by the I that was there already. Alright, so I have 2 imaginary roots here. Alright, let's do the second example where b is odd. Alright, so the first step is to set the equation equal to 0. So we're going to have to move the 3x over. Alright, now we're going to still try to create a perfect square trinomial. Take half of b and square it. Now the problem with this is that you can't half an odd number. You'll get a decimal. So there's not going to be this intermediate step. So we're just going to go straight to the answer. So when we take negative 3 and square it, we're going to square the top and then square the bottom. So negative 3 squared is positive 9. And then when I do the bottom, 2 squared, that gives me 4. So we're going to add that number to both sides and then subtract it. So what we're going to do is we're going to say, okay, x squared minus 3x plus 9 over 4 minus 9 over 4. So we added it in, then we subtract it. That's my 0. Then we have my 10 and equals 0. So now this is my perfect square trinomial. And these two I can add. So let's add these first. All you have to do is just type those into the calculator. And you should get 31 over 4. And some of you are probably thinking, how am I going to factor this? Now, the trick from before will help you. Is that, remember, once we have it and square it, that is what goes into my 2 factors. So technically, if I were to write this out, it would be x minus 3 halves times x minus 3 halves. But we're going to just write that as x minus 3 halves squared. And then plus 31 over 4 equals 0. Alright, so now we're just going to solve. So I'm going to subtract 31 over 4. And again, take the square root of both sides. The square and the square root will cancel each other out. So we have x minus 3/2 equals, don't forget the plus or minus. I'm going to pull out the I while I'm here, and the square root of 31/4. So, to finish this off, I'm going to have to add the 3/2 to both sides. So I'm just going to write that up here. So when I add the 3/2, so plus 3/2 and plus 3/2, I will get x equals 3/2 plus or minus I rad 31/4. Now we can actually simplify this because the square root of 4 is in fact 2, and the square root of 31 we actually can't, so we just leave it as the square root of 31. So we basically are just going to take the square root of the top, which we can't, so we just leave it, and the square root of the bottom, which is 2. And we bring down everything else. And we're all set. And these are my roots. Alright, if you have any questions, jot them down and ask tomorrow in class. If not, have a great night.